So I wanted to make sure that we had a firm understanding of Chapter 4 concepts, which were focused primarily on estimating costs. So if you would please turn to page 116 in your textbook, I'd like to walk through the end of chapter problem 4.1 with you. You'll see problem 4.1 outlines some assumptions, fixed costs, which I've abbreviated here FC of $500,000, variable costs, abbreviated VC of $25 per procedure. And for letters A and B, the question asks you to assume a volume, which I've abbreviated here with the letter V, of 7,500. Now you'll see I've also laid out a spreadsheet here which resembles the example on page 98 and 99 of your textbook. So if you'd like a larger example, you can reference pages 98 and 99 in your textbook. But what I'm looking here, underlying cost structures, if you remember, looks at cost as it relates to volume. So you'll see I have a column for volume, a column for fixed costs, column for total variable costs, column for total cost, and a column for average cost. So we will explore all four of these cost elements for 3 points of volume, 5,000, 7,500, and 100,000. And how I got those three were just from the problems. 7,500 is from questions lettered A and B, and the 5,000 and the 10,000 are going to address questions C and D. So let's get started. When we talk about fixed costs, if you recall, fixed costs are those costs that remain constant over any levels of volume. So here in this case, as it applies, it doesn't matter if the volume is 5,000, 7,500, or 10,000, the fixed cost is going to remain 500,000. So how we represent that in the spreadsheet is by doing the equal sign and referring back to the assumption that we've already outlined. You want to try to avoid manually typing as much as possible because it results in more errors being made. So you can do the B3, and I'm going to do an added keystroke here, pushing the F4 button, which is an absolute reference. If you're not familiar with absolute references, please refer back to the Excel Basics tutorial. So I'm doing an equals B3 with an absolute cell reference, and you can see it points back to the 500,000. Now when I click and drag this, it remains 500,000. So that we have almost a quarter of the spreadsheet done already just by filling in the fixed costs here. For total variable costs, you can see the volume. That's the variable cost times the volume. So you can see the volume changes, but the variable cost doesn't. It's $25 per procedure, regardless of if we're doing 5,000 procedures, 7,500 procedures, or 10,000 procedures. Each procedure costs $25. So this is going to be another case when we set up the formula, we're going to need to do an absolute cell reference. So here, if you follow the formula, the variable cost is $25. We're going to add the absolute cell reference multiplied by the volume. So here we're taking $25 multiplied by 5,000. So if we do 5,000 procedures, the total variable cost would be $125,000. Now we can click and drag because we have the absolute cell reference, and you can see here I just double-clicked in order to get the formula to show in the cell. You can see the cell reference B4 has not changed because of those dollar signs, so it's still $25 per procedure. But now we're saying the number of procedures we're doing is 7,500. So it has updated to cell A9. It's gone down one cell because we've copied the formula down by one row. And the same goes for total variable costs. At a volume of 10,000, you'll see the variable cost still is $25 per procedure multiplied by a volume of 10,000, and that results in $250,000. So now the total cost is really just the addition of the previous two columns that we just got done doing. You can do an auto sum, or you can manually type in the sum function, and here I can just copy and paste, no absolute cell referencing needed, because as I copy and paste down, all of the rows need to be updated. And then the average cost is going to be a combination of the previous column we just calculated divided by volume. That's what that formula is here. Total cost, which is this column, divided by volume. And so you can see here, we can click and drag, and now you have your average cost per procedure. Now you might be thinking to yourself, why is the average cost decreasing as we increase the volume? So see here, you can see we started off at doing 5,000 procedures, we ended up doing 10,000 procedures, but the average cost is decreasing. And the simple fact of that is economies of scale. What we're doing here is distributing this fixed cost of $500,000 across more units of procedures performed. So that essentially decreases one side of the equation, which is the fixed cost. So that's one argument where if you buy, let's say, a Da Vinci robot, you have a fixed cost of, let's say, $2.5 million to buy a robot. That $2.5 million is incurred whether you do one procedure or whether you do 100 procedures. Now, obviously, if you do many more procedures, you're eventually going to have to buy a second robot. But assuming that you're going to do as many number of procedures as one robot will allow in, let's say, a year's period of time, you want to do as many procedures as the machine's capacity will allow, because that will distribute the fixed cost of $2.5 million over that many procedures, making the average cost for each procedure lower. I hope that makes sense. If it doesn't, please post a question to the Q&A discussion forum. Thanks.